All right, guys, here we go. Today, to save time, I'll do instead of doing it on the whiteboard, I'll work with this. So we've added a couple of pieces. So lately, we've been working with a form of integrals. It looks like we say f prime. Uh, oops, sorry. We are we are taking the integral of negative x to the negative 2 power of dx. And then what we end up with is our integral. And it's just a basic integral. So now the idea is this, though. We don't know where it starts, where it finishes. We don't know anything like that. Well, we have two pieces that we add to the integrand. So this here is an upper boundary, and this here is a lower boundary. All right. So something we're going to learn later is let's just assume that we have some function that looks like this. Doesn't matter what it looks like. And we have a lower boundary of A and a upper boundary of B. And what we're really finding when we find the integral of this piece is we're actually finding the area under the curve. And we'll get to that a little bit later. So we're finding the area under the curve. And so the idea is that I'm going to find the area of B minus the area of A. And then when I subtract those two, I get the area between A and B. So how do we find the area? We take the integral. So let's just assume, even though it's not even close, let's just assume that this is that blue line right there. So then what we have to do is we just have to find the area in between these two, and that gives us our answer. That's why we have a upper boundary and a lower boundary. So this is really x equals 1 and x equals 4. So if we integrate this, I always move the negative out front. So let's integrate this. Let me go back to what we were working with. I'm going to take the negative, move it out front, and we have the integral from 1 to 4 of x to the negative 2 dx. So then we are going to integrate this. So we're going to get negative of the integral, which is going to be, we're going to add 1 and divide by 1. So we get negative x to the negative 1 power. And we're going to solve that from 1 to 4. Okay, so that's the idea. And then don't forget, we still have our plus c in here. Okay, we have our plus c, and I'll show you what happens with that. So we have this piece, so let's clean it up just a little bit here, because we know that a negative times a negative is a positive. So I have 1 over x plus c from 1 to 4. Right? So I'm gonna integrate that, and I'm gonna test it from 1 to 4. So what we do is, just like I said prior to this, is we take the upper boundary and we plug it in. So we get 1 over 4 plus c minus our lower boundary, which is 1 over 1 plus c. So if we clean this thing up, I can't It's not scrolling real good today. Let me close this here. If I look at this, these c's are going to cancel, so my answer is going to be 1 over 4 minus 1, which is negative 3/4. So that means the integral of 1 to 4 of negative x minus x to the negative 2 dx is equal to negative 3/4. Okay, so that's how we're dealing with it. We're still taking the integrals, but we're just plugging our upper and lower boundaries in. So if we take their next example, and you got to kind of know some old stuff, guys. You got to deal with trig. Got to love trig, guys. I know some of you don't like trig, but you got to love it. Got to deal with it. So let's just kind of look at this here, and let's say the integral of 2 pi. The integral from pi to 2 pi of the sine of x dx. So let's integrate this. So what's the integral of the sine of x? Keep hearing my computer go off. Integral of sine of x is negative cosine of x plus c, and we're going to evaluate that from pi to 2 pi. And so then we get negative cosine of 2 pi plus c minus, I always put that bracket there to keep track of it, negative cosine of pi plus c. And so if we're dealing with this, we are dealing with negative cosine of 2 pi, negative cosine of 2 pi. 2 pi is all the way around. So what is our cosine value? Our cosine value is 1, so we get negative 1. And negative times a negative is a positive, so we're going to get a plus. And the cosine value of pi is negative 1. C's are going to cancel, so my answer is negative 2. Okay, so that means the integral from pi to 2 pi of sine x dx is negative 2. Let's do one more example for you guys, and that'll give you an idea of how we're dealing with stuff. So they do love to mess with you guys a little bit because I don't know why they think it's fun. So let's pick a different color here. We haven't done blue in a while. So we're going to integrate from 1 to e. Okay, so now you're like, oh, that's a variable. Remember, it's not a variable. What the heck are you doing to us? Remember, this is a constant number. It's approximately 2.71, and it's in your calculator. So don't forget that's a constant. It's not a variable, so we can work with that. So we know we're going to integrate this thing. This is our natural log. So when we integrate it, from 1 to e, we're going to get the natural log of x plus c integrated from 1 to e. Well, we start plugging things in. So now we get the natural log of e plus c minus the natural log of 1 plus c. Don't forget, this becomes 1 minus the natural log of 1. I'll write it that way, of 1. Okay? And so what's the natural log of 1? What's the natural log of 1? Whoops, where am I at here? So natural log of 1, it's going to be 0, so my answer is 1. All right, so that's our way to tackle our brain dead things on Friday. Can't even think what I was going to tell you. But have a great day, and we'll talk to you later.